we all had like an open slate in the manufacturing space about how processes, be it design, be it procurement, be it production, be it how capital is there, could be changed, what would it be? And I think everyone would have a different perspective on this. So I think we could start the ball rolling with this question.
Coming from the investment background, I think one thing which we need to sort of, it's a myth which we not to, need to sort of demystify while we are here is investors don't invest in hardware. We have Aether here, which is invested by some of the largest investors in India and globally. I think what is important to understand is that in manufacturing, when people set out a problem and want to go and achieve that as an entrepreneur or as a startup or as somebody who's trying to help SMBs or enterprise, they need to make it very, very crisp in the sense that if what that I'm building cannot be taken over by somebody who's doing it at a cheaper cost. They should try and work towards something which is non-commoditized, something which is not easily done by reverse engineering, and something which has a long-term vision. I think investors do understand when you have a long-term vision where, rather than fly-by-night operators who come and talk about hardware products they can build in, say, 6 months. I don't think that's when you bite the bullet. But if you're trying to do something which has a long-term horizon, which you know what you want, which you're designing out of India, and which is non-commoditized, I think you are in the right place.
I fully agree with what Swapna has said. I think what needs to change in manufacturing is that engineers should have fun at their job in manufacturing. They should be able to design products, innovate right from an early stage in their careers, and business models should change so that we do a lot more R&D and think long term and build out excellent products that create a lot of benefit, tangible benefit to consumers in the end. So a lot of innovation needs to have a seat at the table in manufacturing startups. I think a lot of you should get into manufacturing startups or think about that very seriously, because there's a lot of money to be made. You'll have fun at your job, and you'll be creating this ecosystem in India where we have the largest number of engineers graduating, and that's our biggest strength. So we should make the most use of that.
Yeah. So there are great points there. I just wanted to follow up on that poll. It was very interesting. I mean, it's a highly fragmented, highly complex, highly siloed industry. And my passion is to be able to break down those silos through communication and discovering the incentives which are there, whether those incentives are profit or waste or collaboration or growth, they exist. And so it's basically putting people in touch with each other, whether it's suppliers and consumers or designers and product development or investors, and entrepreneurs. Those bridges have to be made, and they have to be made much faster and more rapid than is what's happening right now.
I think even today, before the panel, we were sort of having this debate. One thing that I've always believed is that we should not fight losing battles. And every time you end up discussing manufacturing in India, you will we'll all end up inevitably saying stuff like, why do people only want to buy the cheapest product out there, right? Or like, why does everybody want that fancy job in software, right? Like, what's wrong with working in hardware? Well, you just answered yourselves, money, right? Or you just answered yourselves, you're more expensive, customers won't buy you. So I'm not saying, and hence give up, we don't manufacture. All of us here are trying to sort of, work with that constraint. Sometimes you will end up concluding, like often you will in India today, that you can't beat many companies sitting outside India on prices, right? Like whether China or Korea in some cases. Sometimes you'll conclude you can't beat them on quality, right? So maybe we should choose a different parameter to compete on, right? Like there's no point of trying to build the same thing, struggling with like an extremely low margin business and then not going anywhere. Second thing that I believe very strongly is that very few people who are in manufacturing or in the established industry are really thinking long term. Like, and long term is not 5, 6, 7 year thinking. Long term is like a 20, 30 year ecosystem view, right? If you're building electric vehicles, for example, because that's the industry where I come from, there's no point of thinking, how do I get this product out? Like, you will get the product out. Like, everybody builds vehicles in India. Like, there is enough talent to get the product out eventually. But how will you actually sustain yourselves eventually? So you need to be building batteries, and then you will need to be partnering with somebody building cells in India. That means you need to be actually discussing where's the material for these components coming in the long term. And can you forge those partnerships? Can you actually, get into those sort of investments today? And The problem is, and that's the classic VC investment problem, well, that's longer than a 10-year view. Unfortunately or fortunately, that's the sort of viewpoint we need for anybody in manufacturing or any sort of building in India today. You need to have a 20, 30-year view. That's the only way you will look at an ecosystem. And unless you're looking at an ecosystem, the thing is not going to scale. You will hit a roadblock sooner than expected. So two things I believe in strongly.
So when Naman called me for this discussion meeting, I thought I'm going to be an odd man out among venture capitalists, business people, and people who are going to have startups. But then I thought I should share our long-standing experience that we have with our own research and how we try to promote this research into useful product development. I'm really happy to see a lot of youngsters sitting here, so I can probably pass on some useful messages to you. Look, 30 years of research and collaborating with some of the best labs around the world, what I have seen is why India has fallen behind in terms of catching up with the rest of the world. In terms of, we can't name any product that is produced in India. It's not that we are not in a position to produce the kind of quality products that you see from Japan, US, and European countries. It's just that there's a complete disconnect between Indian industry and research labs. I'll give a simple example of the collaborators that I go to every year in Japan. Just like the students and faculty reach the university, the CEOs of all major companies like Panasonic, Sony, Sanyo, they all go to universities, interact closely with small research groups where, you can't expect researchers in universities and institutes to develop products, but then ideas are there. That's where you should get the ideas from. And these ideas are tapped by these Japanese companies, and they go there, spend time, and say, oh, Prof, we know that you're doing this. You bring it to this level, we'll fund it, and then we'll take it up from there. Clear example that I've seen with a little bit of funding is the development of electronic paper, with a group of 5 or 6 researchers. I think this is a main problem in India. We lack the industry academia collaboration, which is changing. I see a big change happening in the last, say, 8 to 9 years. IIT Madras is leading in this initiative. We have what is called a research park, where a lot of incubation is happening, probably one of its own kind in this country. Most of our own undergrads, postgraduates are staying back in the country and taking up the ideas that are developed in the research labs into making products. So manufacturing of mechanical components, electronic components, unfortunately, we have lots of great brains. But then it's because of this disconnect, we couldn't go to the level of what the other countries have gone to. But it's better late than never.
So I think that's great opening thoughts. Right from the financing space to how academia and industry to work, to R&D, to what kind of products to manufacture. So I'll just get into a couple of things we discussed. Was one big thing which came across from all our panelists was that the big thing or the big issue around in India not being a manufacturing powerhouse is not just the manufacturing itself, but the steps prior to the manufacturing, which is the collaborations, the R&D, and the design which goes through it. So I'll just ask Viraj to talk a little bit more about how he is working with some manufacturers on design, and also talk a little bit about his collaboration with another IIT he has just recently did.
All right, sure. So just to give some background, we are creating a science of high-strength engineering and design, where we collaborate with OEMs, original equipment manufacturers, or any company that makes their own physical product. It's their own design. We help them innovate faster and in a much more efficient way with our deep specialized knowledge of high strength. So what the manufacturing industry needs is this whole high quality design coming in at the early stage of product development. Because for a long time, we've been taking product prints from outside India and just manufacturing it. Or we may be going into this model of trying to do what China's doing, which is just the factory of the world, but without doing our own product design. So that's something there's a lot of potential, because with Make in India, there are so many companies that are manufacturing, and small players as well as mid-sized companies that are putting out their own products. So if they have innovation and a strong product design input, they can really capture the market because they know the local needs better than, say, multinationals. And the industry academia collaboration as well is something that helps. Like, we are working with IIT Powai in Mumbai, where they help us with fundamental research, and we take that from a particular level of maturity closer to the industry and OEMs, where they can then commercialize and launch them into the products in the market.
So thanks, Viraj. I was discussing with Swapna, and she mentioned that Qualcomm, not on the venture side, but Qualcomm itself, also does a fair bit of collaboration between the industry side and academia, which I feel a lot of people sometimes not know about. So I would just ask her to a little bit share some thoughts on that.
Qualcomm is this large global giant which is basically part and pervasive of all the mobile phones that you're using today while in this room, right? So Qualcomm understands that these chipsets sort of form the crux of everyday living, and then they can sort of partner with all these new startups to help them get to the next level. So what they have done in India is they have essentially started this Design in India lab. So any of you who are working on hardware startups, this is your opportunity to actually go partner with them, sit out of the labs, work with the best R&D minds and conceptualize your products. I don't think in India you have too many such warehouses which you can make use of. So I would urge anybody who's wanting to start a hardware out of India should make use of this warehouse, learn the best chipsets to use, learn the best workflow to use and get the product out.
In addition to the design and everything which everyone discussed, one really big point which came up during our discussion was also how manufacturing is much, much more capital intensive to get our first prototype or the first product out relative to the software startups or the internet companies you see coming out of India. And I would ask Lakshman here to go back to his manufacturing days, where he spent close to a decade, to talk about the fact that it's being capital intensive. And then I'll come back to my right to Tarun to see how his perspective on it still being capital intensive, because they both followed very different routes to fund their respective businesses.
I spent more than a decade in sort of medium to large manufacturing industries. And the one thing that I see is that, yes, it is capital intensive. And when we say capital intensive, it's not just about the big factories, but it's about inventory. It's about managing losses. It's about credit periods and working capital and all sorts of, hairy things that most people in software don't have to really worry about. And so this has an underlying effect, but where it really creeps into places where you don't realize. You're going into innovation, trying to get into products where you think that the capital intensive nature of it just prevents you from going into it. And so I see a lot of people don't want to get into products because of that capital intensive nature. And I think that is changing. The world is becoming flatter, easier. There is a lot of outsourcing that can happen. There is, communication. You can use, other people's factories. So yes, it's sort of coming down, but definitely the capital intensive nature of manufacturing is one of its biggest problems. And that's why you see a lot of big companies and a lot of small companies, and not a lot of startups and not a lot of medium-sized sort of companies. Yeah.
So Tarun, I'll just ask you a similar question, but would also like for you to think about the early days at Ather, and was it always the same thinking, or this thinking evolved in terms of how you would be eventually funding this new product you're planning to bring to India?
So I agree that manufacturing is more capital intensive, but relatively to the stage, right? Eventually, and it depends, manufacturing is a very, very massive umbrella, but most of the startups that I know in manufacturing actually don't need anywhere close to the sort of capital that many successful internet startups actually need, right? And I was just giving this example, and while I agree, like working capital, working requirements not considered. I was just giving the example when we were discussing outside. The amount of money that Vespa invested in setting up a plant which can churn out 400,000 scooters in a year, right? That's close to 600 million in revenue every year, right? They invested something close to 40 or 50 million dollars. That's it. Like, if we call that capital intensive to reach something close to like $500 million plus in revenue, it's not. It's absolutely not, right? Obviously, that's the amount of that's touching Series B, Series A these days, right? So it's not capital intensive that way, but it is it is a very funny situation for most startups in manufacturing because the gestation period before you get anything out is incredibly long. So for us for example, are actually very interesting case. We're finishing 4 years of existence this October. We haven't started shipping anything yet, right? Our first product ships next year. So, and to be honest, I did not know that when we started. We thought the journey is always going to be 1 year, 2 years long, and just kept on extending. But the challenge there is that, that 3, 4, or maybe 5 years of development is incredibly hard to fund with none of the metrics that a traditional investor is used to, right? Investors are used to working with metrics like, hey, if I give you X amount of money, with that invested in marketing or development, you will get 2x revenue, right, next year, right? You will show me an increase in orders day on day. You will show increase in revenue. Your margins will start becoming less negative, and over the next 3, 4 years, we'll make it big. But the problem with anybody in design or manufacturing is, well, I'll give you money and you will make a prototype, and that's it. Well, then I'll give you 10x more money and you will make a better prototype, right? Then I'll give you 10x more money on top of it, and you will say, now we're getting ready to really start production. So the metric is very confusing for most investors. In fact, it's very confusing even for entrepreneurs, right? What is it? How do you show progress without revenues, margins, profits? You can't call employee or a bigger R&D group as really progress for most investors. So that's the key challenge. The only way to get out of it is to basically build a better and better story, right? Like your prototypes need to convey a better story at every stage. They need to de-risk something else, right? Investors are used to de-risking market share challenge or product market fit. But here you need to explain them that there are other challenges that you're taking off the table, right? There is a challenge if you're building, like, let's say an IoT device, but if you can even make the device, right? There's a challenge if it can fit in the form factor. There is a challenge if you can collect pre-orders, right? Those become the new metric, right? And you're almost educating investors on that, and that's why it's a very different battle.
Can I just add to that? It was more like Tarun was speaking my mind, right? Sitting in my shoes. I think just to add to that, I think like Tarun said, the challenge here is a long gestation period. I think most investors have this small fund life of 5 to 8 years, and they can't envision what will happen after 10 years, right? But I think the other challenge here is also the story that you sell, right? If you are doing a consumer internet startup, you can easily have a copycat model, yet you know there will be adopters, and you can easily sell that product, and you know what the unit economics and matrix look like. When you're doing a hardware out of India, and your simple challenge there is, you can't go with a copycat model, because if you try and doing something which China has already done, you will be able to do it at probably 2x, 3x the cost. You won't find the right market fit, and hence your product won't be a success, right? Which means you need to really find a niche segment wherein somebody else will not come and kill you just on the pricing factor. And let me give you an example. We have done a couple of hardware investments in India. One of them being this indigenous drone company called Idea Forge, which manufactures drones for Indian military. The other is an infrared camera, which again serves Indian military. These two investments were very simple from the thesis that, hey, Indian government needs to purchase some of these military equipments. They will not go to, hey, say China to buy it. Whereas China guy can do it cheaper, I can build far more superior products at a higher price, and yet I know those guys will buy it for me. So they had a very simple thesis and they went ahead with it. And like Tarun said, it was a 5-year journey. Those guys started in 2006, 2007 out of IIT Bombay. Tonvo guys started in 2006, right? They all went to 10 to 11 years. They had the same journey of prototype. They got some funding, angel funding. Then the second journey, when they got the first customer, they got little Series A. And when they're ready for mass market, they got the Series B. But I think he has just hit the nail. You have to be prepared for this long journey, and you need the right investors to partner in. I don't think it's everybody's cup of tea, but you will find your right suitors.
One more thing to add on this perspective between investing and product development. I think we can take inspiration from the pharma industry, where a lot of drug development takes place, and that's a very long gestation period. But money goes into pharmaceutical companies for just drug discovery and crossing certain milestones. So if you apply that same sort of metric, or as Tarun mentioned, crossing certain challenges, at the same time, you create multiple concepts of your designs so that you're hedging your bets. And some of them would work out in the market while the others could fail. That can work in sort of de-risking.
Point well taken. Just on carrying on that point, so definitely if you have a great idea where you could spend time on R&D and have this long gestation period of 8 to 10 years, it's great. But a lot of times, speaking to Professor, he was mentioning about a lot of already intellectual properties which are already housed in IITs, which could be leveraged by entrepreneurs to go out there and start their manufacturing journey. And a lot of things which people do not know about. And I happen to know a friend who did that at IIT Madras. And I would just like Professor to share a little bit more about how entrepreneurs could get in touch with academia to get access to such intellectual property.
It's quite easy. Just send a mail and then you're in touch with me. So we're all always accessible, there's no problem. And I'll start, before I go to this example, I hope, I don't know if you know this or not, the way the GPS system was developed. So in each country, they have funding agencies that fund research for, I write a project, and based on my profile, the funding agency says, okay, we can give this money to these guys. And then we develop something. We also know that this could be taken to the next level. And that's where the industry has to chip in. So in 20 years back, 25 years back, when a group of 4 researchers approached the National Science Foundation for a very small grant, they just wanted to prove the concept of if the GPS thing works or not. And the project was funded with about $20,000, which is a very small amount for, if you're looking at the millions of dollars of funding that goes into research, this is nothing. But they, within 2 years, they came out with a result that, yes, the GPS system really works. Then the industry chipped in. They started making prototype models, and today you know where we are, right? Even on the busiest of Indian roads, GPS system still works. This is one example. And the example about how in US and Japan, especially in Japan, this is amazing. The strong academia industry relations are absolutely amazing. Things are changing in India. As I told you, we have a research park where even a new graduate student can have a startup, and he knows because he's already worked on a project with in a group with a professor, and he knows that, well, this idea could be taken to the product development level. Investment, of course, is required, but the basic research part, if it is done by the people who are supposed to do it, right, you can take a clue from there. So one such example is, the government's policies, sometimes we may feel that they're not so okay, but sometimes they work for good. For example, they went and told the defense people, our defense was spending a lot of money on buying things from outside. And defense budgets are humongous, okay? And then the government went and told them that, look, we don't want you to spend money, throw away money like this, and spend money on product. For example, night vision cameras, which could be developed in this country, but they go and buy these cameras from elsewhere. Okay. So what they did was, this is a small example. The NPO Kochi labs, they, 20 years back, they went around for collaboration with foreign countries to make underwater sonars. And a sonar device is required to detect what kind of enemy is approaching your ship and submarine. France and Russia, when they approached, they were reluctant to collaborate with them, saying that, we have embargoes on your country and all that. So necessity is the mother of all inventions. They sat at the table, and then they started developing their own products. And today, they make their own underwater sonars, which are very heavy. Okay. Then, after 20 years, recently, 3 years back, they approached us, because we work on this thin film growth of materials. And thin films, of course, are used everywhere, our cell phones and your laptops. That's where the thin film technology goes in. They said that, look, we are making these underwater sonars with this PZT, piezoelectric materials. The sonar works, but then the device that weighs about a ton is attached to our ships and submarines, and they want to reduce the weight. Within 2 years, we developed the technology for them. So it's cost effective for them, and they could straight away take what has been developed in the lab. In a similar way, we got a very small funding from Department of Science and Technology with our idea on thin film growth technology, we said that, look, if I have a surface which is wearing out over a period of time, let's say, how do you prevent wear resistance? Now I have a machine tool, and precise machining and drilling is required for many aerospace applications, right? Very precise drilling. And you can't use a normal tool made of stainless steel because that wears out within no time. Then you go for a tool which is made of hard material like tungsten carbide. But tungsten carbide costs about 20 times more than normal tool made of stainless steel. But then even tungsten carbide starts wearing out over a period of time, and industry wants to improve the lifetime of these tools. So one such thing that we undertook with a little funding from the Department of Science and Technology is to have coatings on these tools, and we have succeeded in doing that. These are diamond coatings. And you know, when we went around and saw who else is making diamond tools, diamond-coated tools, we have seen no manufacturer in this country. So that's where one of his friends, the Calcutta-based business person, because of his education in NUS Singapore, where he saw how things developed at the laboratory level are taken to the industry level, he's taking it up now.
So thank you, Professor. I think this is just a first step which we at TechSparks have taken towards embracing more about how manufacturing, IoT, and hardware startups, both from the product perspective and the process perspective, can improve, be it on the R&D, be it on the capital, as well as the industry academia side. And it's really fitting that we're not too far from Bangalore's industrial area of Pinya industrial area at Yashwantpur here to have this panel discussion. And I definitely hope that in the future events, such sessions would gain more prominence, and digital startups and hardware startups would grow at a similar rate. So thank you, everyone.